Okay, good morning everyone. So we will continue our lecture for chapter 1. Okay, so now we are going to look at sampling, storage and sample preservation. So previously you have looked into the general steps in chemical analysis, the quantitative, qualitative, okay? How are you going to find the methods? What are the differences between standard methods, journal methods? Okay, so all of that is very important for you to be able to justify on your chosen methods and chosen instruments. Okay, so sampling, senang cerita sampling ni macam mana awak nak ambil sampel tu. Okay, so sampling is a process to get a representative and homogeneous sample. Okay, representative here means that you need the content of the analytical sample must reflect the content of the bulk sample. So that is meant by representative. Okay. What is homogeneous? Homogeneous means that the analytical sample has the same content throughout. Okay. So how are you going to decide? How are you going to obtain a sample for the analysis? So there are three things. You need to depends on the size, the physical state, whether it is a solid, liquid ataupun gas, and the chemistry of the material to be assayed. Okay? So steps involved in sampling a bulk material. So you need to identify the population from which the sample is to be obtained. You need to collect a gross sample that is truly representative of the population. And lastly, you need to reduce the gross sample to a laboratory sample that is suitable for analysis. Okay. Later on, you will see on the distribution of it. Okay, sampling solid. So now we are going to look at how are you going to sample solid, how are you going to sample liquid, and how are you going to sample gas. Okay, so sampling solid. Okay, solid ni there are some difficulties. Alright, solid they ada inhomogeneity. Okay, inhomogeneity. Inhomogeneity of a material which makes sampling of solids is much more difficult. So the easiest way to sample solids is by grab sample. Okay, the sample is taken at random and assumed to be representative. So for you to be able to do sampling and get a much more reliable results, you need to take about 1 over 50 to 1 over 100 of the total bulk. The larger the particle size, the larger the gross sample that it should be. Okay, so for example, when you have like a 1 ton of apa 1 ton of rice, okay, 1 ton beras. So macam mana awak nak sampling those beras? Okay, you need to get 1 over 50 ataupun 1 over 100 depending on the total bulk lah. Okay, so usually kita ambil 1 over 50 or 1 over 100. Okay, so example kat sini kalau kita tengok the stockpile of grains. Ni adalah stockpile of grains. Take increment from the surface and the interior via grab method or motion method, conveyor belt. Okay, so basically this is not that very important, but the important thing is that for you to be able, when you sampling solid, you get about 1 over 50 or 1 over 100 of the total bulk. Okay, so kalau compact solids, contohnya kalau metal ke, alloy ke, ataupun macam wood ke, so obtained by random drilling or by sawing across the metal at random intervals. Okay, so basically we use a random sampling. Okay, so basically when you obtain tadi apa beras tu, okay, you ambil je banyak sekali. Obtaining a random sample from a bulky material can be achieved while the material in motion. Ni kalau kita ada conveyor belt lah. Kalau dekat dalam kilang, usually it will be transported using a conveyor belt. Dekat sini you pilih je mana-mana yang you nak. Okay. So the gross sample yang kita ambil tu, katakanlah from 1 ton you ambil 100 kilo. Tapi you takkanlah nak ambil 100 kilo tu nak bawa balik kepada lab 100 kilo, tidak. So from the 100 kilo, which is our gross sample, it needs to be reduced in size to a laboratory sample. So macam 1 kilogram. Okay, so we will use coning and quartering method. Okay, coning and quartering method ni, the sample is crushed and mixed to form a conical pile. Ni form conical pile. Then the pile is flattened. Bila flatten, kita cut into quarters. Ada 4 quarters of a flatten circle ni ada, it will cut into 4 quarters, and 2 opposite quarters are chosen at random, so we just choose 2 opposite quarters, so until the gross sample is small enough to be transported to the laboratory. So it is wise lah daripada 1 ton to 100 kilo to 1 kilogram. Okay, so this is important lah for you to be able to sampling for solids. Okay, sampling liquid pula. Okay, sampling liquid sample are much more homogeneous as compared to solid sample. Okay, so the gross sample for sampling liquid can be relatively small. If liquids are not homogeneous and only have small quantity, it can be shaken and sampled immediately. For example, kalau you nak ambil air sungai yang berkeladak. Okay, sungai yang berkeladak, usually the keladak is the sand yang ada dekat dalam sungai tu. So you would just need to make sure that it is uniform throughout your sampling process. So you make sure that you sample it right away. Like later on dekat dalam botol tu, you akan nampak tu ada 2 fasa lah. There will be 2 phases. One phase is the sand phase and the top phase is the liquid phase. Okay, sampling techniques for liquid, it will depend on the type of liquid. Okay, so for example, so this is an example. Okay, large volume of fluids, of liquids. Okay, so usually sample after transfer using a pipe ke macam tu, ataupun kalau large stationary liquids. Okay, large stationary liquids, for example, seas, rivers, reservoirs. Okay, so we will use a sampling punya apparatus untuk ambil at the different depths. Okay, kalau large stationary liquids, usually we will take the sample at different depths. Okay, dekat kedalaman yang berbeza. Ada dalam atas, ada yang bahagian paras atas, ada bahagian paras di tengah-tengah, ada yang paras bawah sekali. It depends on the compound of interest. Kadang-kadang you punya compound of interest itu berada di dasar. So you need to be able to get at the bottom of the lake ataupun seas ke rivers ke macam tu. Some analyte dekat surface. Okay, so all of this will be analyzed individually. Okay, and lastly is biological samples. Biological samples ni it will be taken, for example, using syringe. Okay, so all of biological samples needs to have extra care as compared to sample yang lain. Okay, alright. So this is the sampling for liquids, that is sampling apparatus for liquids. You can see that. So this is like a hole, the belakang ni pun hole yang mana dia akan diletakkan at our depth, yang mana-manalah awak nak pilih, macam awak nak letak ke kedalaman 1 meter, 2 meter, 3 meter. So bila dah sampai kedalaman itu, you just release your lever and it will just close. So this top thing will be closed and that also will be closed, trapping your liquid inside. Okay, you see that. Alright. Okay, how about sampling gas? Okay, tadi kita tengok solid, now and then we have looked into liquid. Now we are looking for gas. Gas tends to be the most homogeneous. Okay, large volumes of samples are required because of their low density. Okay, examples, kalau environmental air analysis, it will use a high vol sampler which contains filters to collect the particulates inside the air. Okay, kalau breath sample tu using just a sampling bag je lah. You just blow into this bag and your air from your breath will just be collected into this bag. Okay, it's quite straightforward lah for gas. Alright, so after you have done your sampling, then you will need to know about your sample storage and sample preservation. Okay? So the objective of sample storage and preservation ni is to ensure that we preserve the nature of the analytes as similar as possible during the sampling process. Okay, the sample container yang kita guna untuk sampling itu can introduce either positive or negative errors in our measurement later on. Okay, so that's why we want to ensure that the sample is being stored in a container that will introduce the least amount of errors during our measurement. Okay, in terms of preservation, usually we will just refrigerate or freeze the sample. So in this case, kalau refrigeration, freezing ni is much more towards liquid lah. Okay, to prevent the decomposition. And then usually for liquids as well, kita ambil, kita guna acidified. The container is being acidified with 10% nitric acid. Okay, and then we also prevent the precipitation of metals from water sample. Okay. So these are the containers that are usually being used for sampling. Kita ada metal containers for hydrocarbon. Kita ada amber vials for liquids before light sensitive samples. And we have polyethylene bottle for inorganic trace analytes. Okay. Alright, so this is some exercises for you to be able to do. Alright, so for example, for oil spills, okay, kita tengok kat sini, oil spills dekat sea, dekat laut. So how would you do your sampling? Okay, how will you do your sampling? You nak ambil kedalaman mana? Sama ada di atas saja, di bawah ataupun di tengah-tengah. So you justify. Okay, how will you store the sample? And how will you do the physical separation? So all of this you need to jot down in your mind map. Okay? Kalau ini pula, for example, oil dekat sea. Oil dekat pantai. Macam mana? Oil spill dekat beaches. So macam mana awak nak sample benda-benda ni? Okay? And this is the sampling of gases. Macam mana you nak ambil gas kat sini? Okay, so based on what we have learned before, you just jot down in your mind map. Okay, alright, thank you.